Last key skill in this series on complex numbers is your beginner series. Good job, stick with me. You're going to need 2 of the previous key skills to know how to rationalize the denominators of complex numbers. So if you've skipped multiplying with complex numbers, in fact, if you skipped anything, just go back and watch it all because this will not make sense to you. So we have been given a complex number, which is a fraction or a quotient, one complex number divided by another complex number. And we've been asked to express it as a single complex number. So we can clearly see the real part and the imaginary part. There's a little bit of a trick here. What you want to do is you take your complex number and you look at the denominator. The denominator is the one on the bottom here. And you find its conjugate. So remember from the previous key skill, to find the conjugate of a complex number, we need to change the sign on the imaginary part. And you're going to multiply both the numerator and you're going to multiply both the numerator and the denominator by the complex conjugate of the denominator. So I'm going to say here I need to multiply by the conjugate of the denominator and here too. This is actually the same as multiplying by 1 because 5 minus I divided by 5 minus I would be 1 in the same sense that 10 divided by 10 or 3 divided by 3 is still 1. So I'm not changing the complex number, I'm multiplying by 1, but I'm going to change the format so that we can see clearly what the real and the imaginary part is. Now we're going to need those skills I mentioned before about multiplying out double brackets, which include complex numbers. Now, let's start with the top. We're going to multiply 2 times 5 is 10. 2 times minus I is minus 2i. Minus 3 times 5 is minus 15i. And minus 3i times by minus I as plus 3i squared. Should be pretty good at knowing what to do with that I squared by now. Now let's have a look at the denominator. The denominator by design will end up as a real number only. There'll be no imaginary part. And if we think about that, why that happens, well, if I multiply 5 by 5, I'm going to get 25. Here I'm going to multiply 5 by negative I and get negative 5i. And here I'm going to multiply I by 5 and get positive 5i. So we're always going to have the case that we're going to have a plus and a minus multiple of the I because of this different signs here. And they're always going to cancel each other out and leave no imaginary part behind. Because when we multiply, for example, here, plus I times minus I, we're going to end up with an I squared. Well, we can say that I squared is minus 1, and that means there's going to be no imaginary part left at all in the denominator, which is exactly what we want. So here we're going to say 25 take away I squared, 25 take away minus 1. Remember, I squared is minus 1. So that double minus is going to leave us with 26 on the denominator. On the numerator, again, we're going to change I squared to minus 1, so that's going to give us minus 3 here. And we're going to add together the imaginary parts. So when we simplify that down, we're going to end up with 7 minus 17i divided by 26. And so that we can identify a and b, I'm going to split the denominator to be 7 divided by 26 minus 17 divided by 26i. So this is going to be my a, 7 over 26, and minus 17 over 26 is going to be my b. In case that was a little bit too quick, I'm going to have a second example which we're going to do right now. Let's begin the process again. I need to look at the denominator. I always think denominator down, that's the bottom of the fraction, and find its complex conjugate. So I want to leave the real part alone and I want to change the sign on the imaginary part. So that's going to be 4 add 7i. So that I'm multiplying by 1, I'm going to have 4 add 7i on the top and bottom. Because 4 add 7i divided by 4 add 7i is just 1. So let's multiply out those brackets. Remember, by design, the denominator will end up as a real number. So the denominator would be 16. It would be plus 28i, take away 28i, which would cancel out. Minus 7 times plus 7 would be minus 49, minus 49i squared. Remember that I squared is going to turn to minus 1. And the top we're going to have 1 times 4 is 4. 1 times 7i is 7i. 2i times by 4 is going to be 8i. And we're going to have 14i squared. We are nearly finished. Hang on. So on the bottom, we're going to have 16 add 49 because I squared is minus 1 times by minus. We're going to have here that 4, I squared is going to change to minus 1, so that's going to become minus 14. 4 add minus 14 is going to be minus 10. And 7i add 8i is going to be 15i. So let's have a look. What's 16 add 49? Okay, that's going to be 65. Minus 10 add 15i. We can split them up into minus 10 over 65 and 15i over 65. And the last little step is going to be, as always, we need to cancel down our fractions. We can divide both of these by 5. And both of these by 5. And you are done. Congratulations. I'm going to do 2 more series on complex numbers. One is going to be complex numbers and polynomials. And one is going to be expressing complex numbers in polar form and expressing complex numbers in terms of Euler's numbers. So that is going to be your next step to level up your knowledge of complex numbers. But congratulations, I feel like you've got all the basic skills you need: multiplying, adding, dealing with complex fractions. So I want to say congratulations, good job, and I'll see you in the next series. Bye for now.